Okay, next we're going to talk about Objective 10 on the second 9 weeks, which is on imaginary and complex numbers. An imaginary number is any number of the form a plus bi, where a and b are real numbers and b does not equal 0. Now, when you combine the real and imaginary part, it makes what's called a complex number. And those are in the form of a plus bi, where a is the real part, which basically just means it's going to be a number, and bi is the imaginary part. Now, some properties of complex numbers that we need to be concerned about. I squared is -1, and that's just kind of a common fact that we got to know and memorize, and we'll use the fact that I squared equals -1 when we multiply or divide complex numbers here in a little bit. Conjugates are kind of the opposite sign in the middle, so if I had the conjugate of a plus bi, that would be a minus bi. The conjugate of 3 minus 2i would be 3 plus 2i. So you just change the sign in the middle. We use the conjugates when we want to divide complex numbers. And we do that so we don't have an I or an imaginary number in the denominator. So I know we haven't worked with imaginary numbers, but it's really a lot like like terms and the the generic rectangle and the box and things like that. So first, let's talk about adding or subtracting complex numbers. So if I want to add complex numbers, so say I want to add 6 plus 3i, and I want to add to that 8 minus 9i. So we're going to add together the real parts and add together the imaginary parts, similar to like terms. So I know technically there's an imaginary 1 in front here and here, but that doesn't really do anything because I'm adding. So really this is just 6 plus 3i plus 8 minus 9i. So again, the like terms would be the real parts, so 6 and plus 8 is 14, and the imaginary parts, so a positive 3i and a minus 9i is just negative 6i. If we subtract complex numbers, here we have 4 minus 2i minus negative 7 minus 5i. So there's an imaginary 1 here which isn't going to do anything to that parentheses, so it's just going to be 4 minus 2i. But here if I have an imaginary 1, since this is a minus, we treat this as a -1. So a negative times a negative would make that positive 7, and then a negative times a negative would make that positive 5i. And then again, you combine your real parts, so 4 and positive 7 is 11, and then negative 2i and positive 5i is positive 3i. So again, that's how you add or subtract like terms. Like I said, add or subtract complex numbers, very similar to the like terms. Next, we're going to look at multiplying complex numbers. So say I want to multiply something like 7 plus 2i times 4 minus 3i. So we're going to do this by using the Punnett square, similar to when we multiplied binomials. So I've got 7 and 2i and 4, and since it's a minus 3, I put negative 3i. So now when we fill this in, 7 times 4 is 28. 7 times negative 3i is negative 21i. 2i times 4 is 8i. Now here's where we got to be careful. It's 2i times negative 3. So that's negative 6i squared. Now this is where that property comes into play. I squared is a -1. So really this is saying negative 6 times negative 1, which would make that a positive 6. Now when you write your answer, you're going to combine your real parts. So now I have a real part of 28 and 6, which would be 34. And I have an imaginary part of 8i and negative 21i, which would be minus 13i. So let's look at another one. We got 3 minus 5i times 4 minus 6i. So we got 3 minus 5i, 4 minus 6i. So 3 times 4 is 12. 3 times negative 6i is negative 18i. Negative 5i times 4 is negative 20i. Now, negative 5i times negative 6i is positive 30i squared. Again, this I squared is going to change this sign because I squared is negative 1. So this is like 30 times negative 1, which is negative 30. So then when I add together the real parts, 12 and negative 30 is negative 18. Negative 20i and negative 18i is negative 38i. The last thing we're going to do with complex numbers is divide complex numbers. Now, in order to do that, we need to multiply the top and bottom by the conjugate of the denominator. So again, we want to multiply the top and the bottom by the conjugate of the denominator. Again, we talked about in the first page there, the conjugate means I'm just going to change this sign. So I'm going to multiply by 5 minus 2i on the top and bottom. Well, you may say, well, how am I going to do that? Well, if I'm multiplying 3 plus 4i times 5 minus 2i and 5 plus 2i times 5 minus 2i, I'm just going to have two separate Punnett square problems. So if I take the top part over here, I've got 3 plus 4i and 5 minus 2i. 3 times 5 is 15. 3 times negative 2i is negative 6i. 4i times 5 is 20i. 4i times negative 2i would be negative 8i squared. But again, I squared is negative 1, so this means negative 8 times negative 1, which is a positive 8. So if I combine my real parts, 15 and 8 is 23. 20i and negative 6i is positive 14i over. Now I need to do a Punnett square for the bottom. And here's the reason we do the conjugate, because you're going to find out the i's are going to drop out. So we have 5 plus 2i and 5 minus 2i. 5 times 5 is 25. 5 times negative 2i is negative 10i. 2i times 5 is 10i. And 2i times negative 2i is negative 4i squared. Again, I squared is negative 1, so this is negative 4 times negative 1, which is positive 4. Now if you add your real parts, 25 plus 4 is 9. 10i and negative 10i would actually cancel. So then my answer is 23 plus 14i over 9. So again, we do the conjugate to get rid of that I on the bottom. So if we look at one more example. So say we had 6 plus I divided by 3 minus 4i. So again, we would multiply the top and bottom by the conjugate of the bottom. So that'd be 3 plus 4i. So if we do a Punnett square for the top, I have 6 and an I and 3 and a 4i. 6 times 3 is 18. 6 times 4i is 24i. 3 times I is 3i. And I times 4i is 4i squared. But again, I squared is negative 1. So 4 times negative 1 is negative 4. So on top, 18 and negative 4 would be 14. 3i and 24i would be 27i. Then if I do my Punnett square for the bottom, got 3 minus 4i and 3 plus 4i. 3 times 3 is 9. 3 times 4i is 12i. Negative 4i times 3 is negative 12i. Negative 4i times 4i is negative 16i squared. Again, I squared is negative 1. Negative 16 times negative 1 is positive 16. So 9 plus 16 is 25. Negative 12i and 12i drop out.